generative AI technology continues to advance, roles like Gen AI engineers and Gen AI specialists are experiencing high demand. Well, Gen AI engineers focus on designing, developing, and deploying AI models, while Gen AI specialists concentrate on applying these models to real-world use cases, aligning them with business objectives and driving innovation. And in terms of salary, Gen AI engineers in India earn between 8 lakhs to 15 lakhs annually, while in the United States, they earn between $100,000 to $150,000 annually. Similarly, Gen AI specialists in India earn between 12 lakhs to 25 lakhs per year, while in the United States, they earn an average salary of $120,000 annually. So, as these roles grow, the competition for jobs increases, so preparing for interviews is crucial. So let's dive into the top generative AI interview questions you should know. Hello everyone, welcome back to another interesting video by Edureka on generative AI interview questions. Before we begin, please like, share and subscribe. Remember to hit the bell icon to stay updated on the latest content on the Edureka's YouTube channel. Also, check out the Edureka's Generative AI certification course, the link to which is in the description box below. So let's get started with our first question, that is, how traditional AI different from generative AI? Now, let's take a look at the differences between traditional AI and generative AI. Traditional AI relies on predefined algorithms and primarily works with labeled, supervised data to solve specific problems, whereas generative AI uses advanced learning techniques to understand data structures, train on datasets, reason, and create new and innovative solutions. This ability to generate fresh output sets generative AI apart from traditional methods. Let's compare traditional AI and generative AI based on their functioning. So in traditional AI, the process typically involves data collection, model selection, training the model, evaluation, feedback, and finally deployment. And on the other hand, generative AI starts with data preprocessing, followed by AI model training, data generation, identifying patterns, and iterative training that incorporates feedback and acknowledgement. Once defined, the model is then deployed. And this iterative and creative approach makes generative AI more dynamic in its application. Well, the key differences is that traditional AI works on predefined rules while generative AI does not. So here are some examples to differentiate traditional AI and generative AI. Traditional AI is used in applications like image detection, stock market prediction, fraud detection, and voice recognition. Whereas generative AI is utilized for tasks such as content creation, predictive fashion trends, code generation, and advancements in healthcare industries. Moving on to next question. How does generative AI help in scaling businesses? Well, generative AI helps businesses scale by automating and optimizing process, creating personalized customer experience, and generating data-driven insights. Here's a breakdown of how it contributes. First, efficiency and automation. Generative AI automates repetitive tasks such as content creation, customer service via chatbots, and report generation, freeing up human resources for strategic activities. Next, pattern recognition. By analyzing vast data sets, generative AI identifies trends and patterns, enabling businesses to make proactive decisions, optimize operations, and predict market shifts. Next comes the content creation. It generates high-quality marketing materials, product descriptions, and creative assets at scale, which reduces the cost and production time. Next, personalized experience. AI customizes interactions and recommendations for customers, improving satisfaction and loyalty, which are critical for scaling. Next is the rapid prototyping and deployment. Generative models create simulations, prototypes, and even entire product designs, accelerating product development cycles and reducing time to market. And finally, enhanced decision making. AI-powered tools provide actionable insights and forecasts, guiding businesses in resource allocation, market strategy, and scaling efforts. Well, generative AI acts as a catalyst for growth by delivering scalable, innovative solutions that adapt to the dynamic demands of modern business environments. Moving on to our next question, what are some common applications of generative AI in real world? Generative AI has the wide range of application in real world like gaming. In the gaming industry, renowned companies like Nvidia and Ubisoft are utilizing generative AI to enhance various aspects of game development and player experience. Generative AI is being used to boost creativity, improve screen time dynamics, refine shadow techniques, and elevate the overall player experience, making games more impressive and engaging. Next, in content creation. So in the field of content creation, companies like Microsoft Azure and OpenAI, the creators of ChatGPT, are developing advanced algorithms to generate unique and innovative content. This content not only captivates audience but is also highly appreciated by critics, showcasing the transformative potentials of generative AI in creative industries. Next, in fashion and design. In the fashion and design industry, companies like H&M Group and Nike are leveraging generative AI to offer personalized clothing, shoes, and accessories online. This innovative use of AI has brought significant advancements, enabling these brands to enhance customer experience and set new standards in personalized fashion. Next, in healthcare industries. Well, in the healthcare industries, companies like Atomwise and In Silico Medicine are utilizing generative AI to enhance efficiency and accuracy in medical care. Given the critical importance of precision when it comes to saving lives, generative AI plays a pivotal role in advancing medical research, diagnostics, and treatment solutions. Next, in chatbots and virtual assistants. So to enhance user experience, major companies like Google, Microsoft, and IBM are developing advanced chatbots and virtual assistants. These AI-driven tools aims to provide personalized support, improve efficiency, and streamline communication, making interactions more initiative and engaging. So, our next question is, what are some popular generative AI models you know? So, first one we have is GPT. GPT stands for Generative Pre-trained Transformer Series, a series of language models designed to generate human-like text based on pre-trained data, enabling tasks like text generation, translation, and even summarization. Next, we have BERT, Bidirectional Encoder Representations from Transformers, a language model that understands context in both directions like left to right and right to left to improve tasks like question answering and language understanding. The next generative AI model is DALL-E and DALL-E 2, AI models capable of generating images from textual descriptions, with DALL-E 2 offering enhanced image quality and more accurate interpretations of complex prompts. Now, moving on to our next question, what are some challenges associated with generative AI? Some key challenges associated with generative AI include data privacy and security. Large dataset used for training may compromise user privacy or include sensitive information, leading to regulatory and ethical concerns. Next, bias and fairness. Generative AI can amplify biases present in the training data, resulting in outputs that are unfair or discriminatory. Next is the quality and accuracy. Ensuring the quality and factual accuracy of AI-generated content is difficult, especially with diverse and large datasets. And the next challenge is interpretability and transparency. Generated content can lack traceability, making it hard to explain or justify outputs. Potential for content to closely resemble on copyrighted material. And the next challenge is ethical concerns. Misuse of generative AI for malicious purpose, such as creating deepfakes, spreading misinformation, or automating spam. Next, resource intensity. Training generative models requires significant computational resources, leading to high cost and environmental concerns. And finally, deployment challenges. So ensuring robust, scalable, and safe deployment of generative AI models in real-world application is complex. And addressing these challenges requires a combination of technical solutions, ethical guidelines, and legal frameworks. Moving on to next question, what is the large language model and how is it used in generative AI? Well, a large language model is a type of artificial intelligence model that has been trained on vast amounts of text data to understand and generate human-like language. And these models are typically built using deep learning architectures such as transformer-based models like GPT, BERT, and T5, and contains billions to trillions of parameters that help them capture the details of natural language. And some of the key features of LLMs include the massive scale. LLMs are trained on extensive datasets that includes a variety of domains such as books, articles, websites, and more. The next feature is contextual understanding. LLMs can understand the context of words, phrases, and sentences by processing long-range dependencies, making them capable of generating coherent and contextually relevant text. Next, transfer learning. Pre-trained LLMs can be fine-tuned on specific tasks or datasets, allowing them to perform a wide range of language-related tasks with minimal task-specific data. But how LLMs are used in generative AI? Well, it is used in text generation. LLMs can generate coherent and human-like text based on the prompt. Like for example, GPT-3 can write articles, create dialogues, generate poetry, or even code. Example, given a prompt like write a story about a dragon and a wizard, the model generates a creative and coherent story. Next, it is used in text completion. LLMs can predict and complete sentences or paragraphs based on the initial input, making them useful in applications like auto-completion, chatbots, and writing assistants. Next, LLMs are used in translation and summarization. LLMs can translate text from one language to another or summarize long documents into concise summaries, making them valuable for tasks requiring cross-lingual understanding or information distillation. Next, in conversational agents. LLMs power conversational AI systems such as chatbots, virtual assistants, that can understand and respond to user queries in natural language, offering more dynamic and human-like interactions. It is also used in creative content creation. LLMs are used to generate creative content such as articles, marketing copy, and even scripts for videos or films. Next, in sentiment analysis and classification. LLMs can be used to fine-tune to classify text, like example sentiment analysis, spam detection, by predicting labels based on context and training data. Next, what are some common applications of large language models? So some of the common applications of large language models include chatbots and conversational AI, powering virtual assistants and customer support bots to engage in natural language conversations. Next, language translation, translating text from one language to another while preserving meaning and context. Also, in summarization, automatically compressing large documents or articles into concise summaries. And you can also give examples of sentiment analysis, which determines the sentiment or emotional tone of text for applications in social media monitoring, customer feedback analysis, and more. Also in code generation, where it is assisting in programming by generating code snippets based on natural language descriptions. And the next question is, what is prompt engineering and why is it important in generative AI? Well, prompt engineering is the process of designing and refining prompts to effectively guide the output of a generative AI models, particularly language models like GPT. In the context of generative AI, a prompt is an input or instruction provided to the model, which it uses to generate a response or output. The quality, clarity, and structure of the prompt can significantly influence the model's output, making prompt engineering a critical skill in maximizing the performance and usefulness of these models. The image shows the concept of prompt engineering, emphasizing its role in optimizing interaction with AI systems. It highlights three key objectives: improving accuracy, which ensures precise responses, enhancing relevance, which tailors outputs to user needs, and increasing efficiency, which streamlines process for better performance. And together, these elements demonstrate how effective prompts design can significantly improve the overall functionality and outcomes of AI models. Next, how does generative AI handle the creation of text-based content? So, the generative AI generates text-based content through a process that involves several key steps. Here's a simplified explanation. First, training on large data sets. Pre-trained on large data sets, AI models like GPT are trained on vast amounts of text data from diverse sources such as books, articles, and websites. This extensive training helps the model to learn language patterns, context, and general knowledge, forming the foundation for its ability to perform various language tasks effectively. Next, the architecture of the model. Generative AI models are built on the transformer architecture, a highly effective framework for processing sequential data. It leverages mechanisms like self-attentions to understand context and relationships within text, enabling tasks such as language generation and comprehension. Next, generating responses. The generation process involves multiple stages, including structuring ideas, connecting relevant information, analyzing data, writing coherent content, and finally deploying or delivering the output in a meaningful and usable form. Next, iterative process. In simple terms, it means improving the model by training it, receiving feedback, and making adjustments based on that feedback to enhance its performance. So in summary, generative AI models like GPT generate text by predicting word sequence based on learned patterns from extensive training data, while understanding and maintaining context throughout the generation process. Examples of generative models include GPT-4, BERT, Transformers, and T5, which stands for Text-to-Text Transfer Transformer. Moving on to the next question, can you explain how generative AI is used in chatbots or language translation? Generative AI enables chatbots to produce contextually relevant, coherent, and human-like responses, improving the user experience. Key areas where generative AI contributes include generating responses. By leveraging large language models, generative AI can produce more natural and engaging responses, making chatbot interactions feel more human-like. Next, creativity. Generative AI can be used to generate creative content such as poems, stories, or scripts, which can be incorporated into chatbot conversations to make them more entertaining and engaging. Next, personalization. Generative AI can analyze user data to personalize chatbot responses, making the interaction feel more tailored to the individual user. And then we have context management. Generative AI can maintain context throughout a conversation, allowing chatbots to understand and respond appropriately to the user's evolving needs and preferences. These capabilities of generative AI are transforming how chatbots and language translation tools are used, making them more effective and user-friendly. Now, moving on to the advanced level questions in generative AI. And the question is, what is the role of the data in training generative AI models? Data plays a crucial role in training generative AI models as the quality, quantity, and diversity of the data significantly impact the model's performance and output. Here are some of the examples of data usage in generative AI models. First, in image generation. For models like GANs, large datasets of images are used to teach the models how to generate realistic images. Next, text generation. For models like GPT-4, vast text from various sources like books, articles, websites are used to train the model to understand and generate human-like text. And next, in music generation. Models trained on large collections of musical compositions learn patterns in melody, harmony, and rhythm to generate new music. Now moving on to next question. How do attention mechanisms enhance the performance of generative AI models? Well, attention mechanisms significantly enhance the performance of generative AI models by allowing them to focus on relevant parts of the input data when generating each part of the output. So here's how they work and contribute to improved performance. The text at the top states that the attention mechanism is a critical innovation that enhances the performance of generative AI models. The diagram shows how multiple attention heads process information in parallel. Each attention head focuses on different aspects of the input sequence, allowing the model to capture complex relationships and dependencies between different parts of the data. The outputs of these attention heads are then concentrated and processed further to generate the final output. This multi-headed attention mechanism enables the model to learn more detailed representations of the input, leading to improved performance in tasks such as language translation, text summarization, and image generation. And the next question is, what is GANs, which stands for Generative Adversary Networks, and how do they function? GANs are the type of generative models that are particularly powerful for generating realistic data such as images, text, or audio. The diagram provides a clear visual representations of a GAN's architecture and its functioning. Well, GAN, which stands for Generative Adversarial Network, this is a central component. It highlights that a GAN is a system consisting of two main subnetworks. Next, generator. Generator is responsible for creating new data samples. Well, it takes input and attempts to generate realistic data points, example, images, text, that mimics the training data. Next is the discriminator. The discriminator acts as an evaluator. It takes an input both real data samples from the training set and the generated samples from the generator. Its task is to differentiate between the real and fake data, assigning a probability of being real to each sample. Now, let us see the functioning of GANs. GANs comprise two key components, a generator and a discriminator. The generator aims to create new data instances that closely resembles the training data, whereas the discriminator acts as a binary classifier tasked with differentiating between real data samples from the training set and synthetic data generated by the generator. The adversarial relationship between the generator and the discriminator drives the GANs to produce increasingly realistic synthetic data. So as you can see the screen, this image shows the functioning of a generative adversarial network. It starts with random noise as input, which is fed into the generator network. This network attempts to generate a fake sample that resembles real data. The generated sample is then presented to the discriminator network alongside actual real samples from the training dataset. The discriminator's task is to classify each sample as either real or fake. So both the generator and discriminator networks learn and improve through this adversarial process, with the generator aiming to produce increasingly realistic samples that can fool the discriminator, while the discriminator strives to accurately distinguish between the real and fake data. Next, how do generative models like GANs help in image generation? Generative models like generative adversarial networks are powerful tools for image generation. GANs consist of two neural networks, the generator and the discriminator, which work together in a competitive process to create highly realistic images from random noises. Here's how GANs help in image generation. Generative models like GANs are powerful tools for creating realistic images. GANs use a dual network approach to achieve this. The generator network creates new images. The discriminator network evaluates these images, trying to distinguish between the real and generated images. This adversarial process forces the generator to create increasingly realistic images. Now, let's see the training process of GANs. In this process, the generator network strives to improve its ability to create realistic images that can deceive the discriminator. Conversely, the discriminator network focuses on enhancing its ability to detect fake images, leading to an ongoing improvement cycle for both networks. Through the continuous adversarial learning between the generator and discriminator, the generator eventually produces high-quality images that are so realistic that they can successfully deceive the discriminator. Moving on to next question, what are variational autoencoders and how do they differ from GANs? Well, variational autoencoders are a type of generative model that is built on the principles of autoencoders, a neural network architecture commonly used for unsupervised learning tasks like dimensionality reduction and feature learning. Key components are encoder. The encoder maps input data, for example an image, to a latent space, representing it as a distribution over latent variables. Next, the output. Instead of mapping to a single point in latent space, the encoder outputs the mean and variance of a Gaussian distribution. This distribution captures the uncertainty in the encoding process. Next, we have decoder. The purpose is the decoder takes the sample latent variables and maps it back to the data space, reconstructing the original input data or generating new data. Output. The decoder produces a reconstruction of an original input or a new data point that lies within the learned distribution. Next, what role can generative AI play in education, especially in creating customized learning materials for students? Generative AI can play a transformative role in education by creating customized learning materials that cater to individual student needs. Here's how it can be utilized effectively. First, in personalized learning paths. Customized content. AI generates tailored content based on a student's learning pace, interest, and proficiency levels. For example, if a student struggles with a particular math concept, the AI can create additional exercise or explanations focused on that topic. Next, adaptive assessments. AI can design assessments that adapt in real time to a student's performance, offering more challenging problems as the student progresses or providing more foundational questions if they encounter difficulties. Next, interactive learning materials. It provides dynamic textbooks. AI can create interactive textbooks that update based on the latest research and educational trends. These materials could include simulations, quizzes, and other interactive elements that respond on how a student interacts with the content. Next, simulations and virtual labs. AI can generate virtual experiments and simulations, allowing students to explore complex scientific concepts in a safe, controlled environment. Next, language and writing support. In grammar and style suggestions, AI can assist students in improving their writing by providing real-time feedback on grammar, style, and clarity. It can also suggest alternative phrases or vocabulary based on the student's level. Next, essay generation assistance. For younger students or those learning new languages, AI can help generate essay outlines or suggest content structure, helping them organize their thoughts more effectively. Next, automated content creation. Lesson plans. AI assists teachers by generating lesson plans that align with curriculum standards, saving time and allowing teachers to focus more on student interaction. Next, practice problems and quizzes. AI can create endless variations of practice problems and quizzes, ensuring that students get the repetitions they need without encountering the same problem twice. Next, support for diverse learning styles. In visual and audio content, AI can generate visual aids like charts, graphs, and diagrams to produce audio explanations for students. Next, AI can also create educational games that are tailored to the curriculums, making learning more engaging and fun for students with the preferences for interactive learning. Well, generative AI in education has the potential to create more personalized, engaging, and effective learning experience for students while also supporting teachers with the tools they need to enhance their teaching. Next, what is the Gaussian mixture model and how is it used in generative AI? A Gaussian mixture model is a probabilistic model used in generative AI. It assumes that data points arises from a combination of multiple Gaussian distribution. The image visualizes the concept, and the first shows a single Gaussian distribution, the second shows a mixture of two Gaussian distributions, and the third row shows data points generated from various Gaussian mixture model configuration. Well, it is valuable in generative AI for tasks like clustering, density estimation, and generating synthetic data. The graph demonstrates data generation using a Gaussian mixture model. After training on a dataset, it can create a new data points by sampling from a learned Gaussian distribution. The graph compares a theoretical normal distribution to data points generated through Monte Carlo sampling from this distribution, showcasing the accuracy of the generated data in capturing the underlying distribution. This technique is crucial in generative AI for tasks like creating synthetic data that resembles real-world data. Next question is, can you describe the concept of a transformer model? The transformer model is a type of deep learning architecture that has transformed the field of natural language processing and more recently has been adapted to other domains like computer vision, introduced in the paper Attention is All You Need in 2017. The transformer model moved away from traditional recurrent neural networks and convolutional neural networks by relying entirely on a mechanism called self-attention. And this graph shows the increasing number of the model parameters in generative AI models over time. As the number of parameters grows, these models gain the capacity to process and learn from more complex data, leading to enhanced performance in tasks like text generation and image synthesis. However, this increase in parameters also comes with challenges such as increased computational cost and the risk of overfiltering, where the model performs well on training data but poorly on new unseen data. The next question is, what are model parameters and how do they affect the performance of generative AI models? Model parameters are crucial components of generative AI models that significantly influence their performance and output quality. These parameters are the internal settings that a model learns from the training data and uses to make predictions, generate content, or perform specific tasks. The process of optimizing model parameters in generative AI starts with importing training data and initializing the model's parameters. An optimization mechanism is then applied to the train and update the model's parameters iteratively. This process continues until the defined closing conditions are met. Finally, the optimized parameters are obtained, which are crucial for the model's performance in generating realistic outputs. Model parameters influence the content generation process, impacting the output quality. These parameters are crucial for feature learning, enabling the model to identify and utilize patterns in the data to generate realistic and meaningful outputs. And the next question is, how can generative AI be leveraged to create personalized experience for users in e-commerce? Generative AI can significantly enhance personalized experience in e-commerce by tailoring content, recommendations, and interactions to individual users. Here's how it can be leveraged. First, in personalized product recommendation. AI-powered recommendations personalize product suggestions by analyzing individual user data. By understanding browsing history, purchase patterns, and preferences, AI algorithms recommend products aligned with user interests, enhancing the shopping experience and driving sales. Next, customized marketing campaigns. AI enables personalized email marketing by analyzing user data to generate targeted content. By delivering messages with relevant products and promotions tailored to individual interest, AI enhances campaigns' effectiveness, increasing engagement and driving conversions. Next, tailored product descriptions and reviews. AI personalizes product descriptions by analyzing user data to highlight features most relevant to them. This enhances the shopping experience and increases purchase likelihood by providing targeted information. Next, virtual assistants and chatbots. AI-powered chatbots function as virtual shopping assistants. They provide personalized product recommendations, answer user queries, and guide them through their shopping journey based on individual preferences. Next, visual search and augmented reality. AI-driven visual search allows users to upload images of derived products. The AI then generates suggestions for similar items available in the e-commerce store, offering a highly personalized search experience. And by leveraging generative AI, e-commerce platforms can create a deeply personalized shopping experience that not only enhances customer satisfaction but also increases engagement, loyalty, and conversion rates. And with this, we have come to an end to this video. So if you enjoyed listening to this video, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. Do look up for more videos and playlists and subscribe to the Edureka's YouTube channel to learn more. Happy learning!